Thank you, everyone. This is the last talk of the day on this side of the world. Finishing strong with some Kotlin Swift craziness, I will say. No spoilers. Big applause for Jonas, please. Enjoy.
All right. So hello, everyone. Let's start with a quick show of hands. Who is a Swift developer here? Okay, a lot of you. Great. Who is a Kotlin developer? Much less. So welcome to Kotlin for Swift developers. My name is Jonas. I'm an iOS and Android developer here at Lip, a great company in Switzerland. I like both platforms, and I really like synergies between the two of them. I like both languages and knowing that what you can do in one platform, you can also do it in the other platform. And that's what I want to share with you today. So the talk is in two parts. First one, differences between Swift and Kotlin. So slides. We'll see the differences only, and what's similar we'll skip. It's not always one-to-one, so when I show something in Swift and something in Kotlin, it's not always exactly the same, but it's to give you an idea. Second part, code demo. So we'll take an iOS app in Swift and convert it to an Android app in Kotlin. So we have a lot to talk about today, so buckle up and let's go. We'll start easy with variable and constants. So in Swift, when you want to declare a variable, you use the var keyword, and then you can change it. And you use the let keyword for a constant. In Kotlin, you also use the var keyword for a variable, but you use the val keyword for a constant. So the only difference here is let and val. Otherwise, it's all the same. String interpolation. So here we'll define a constant called name, Lugano, and then the name Lugano has 6 letters, for example. So in Swift, you would use backslash parentheses for all your expressions, like name or name.count. But for Kotlin, for string templates in Kotlin, if you have the same string, the name Lugano has 6 letters. As you can see, when you have a simple expression like name, you just use the $. But when you have more complex expression, then you use $ and curly braces. So it's a bit easier in Kotlin when you have a simple expression like a variable. Function. So let's define a function in Swift. You use the func keyword. Here, a show alert that takes a title and description. Here, the title is just a string, and the description is an optional string. The description has a default value, nil, so you don't have to use it. And then, as you can see, I use also the underscore, so you don't have to name the description parameter. So the first line, show alert, title, hello, Lugano, and then second best city in Switzerland. You can see that I use the title argument, but I don't use description thanks to this underscore. And then I can also not use the description as it has a default value. In Kotlin, you use fun, so you drop the C, and then you also have a title and a description. Title is the same, a string, and then description and optional string. Here we use null, like in Java, for example, and not nil, like in Swift. Then you can call your show alert method in Kotlin. We don't use parameter names by default. But if you wanted to use them for readability, for example, you could. So show alert, title equal hello Lugano. It's nice in Kotlin because you kind of have the best of both worlds. You can not use the argument name, but if you want to, you could. Classes. So let's define a class, person. This person has a name, an optional string, and it also has a greetings method that returns a string. The body of this function is hello, name, or stranger. If you know this double question mark, if name is nil, then we'll use stranger. If name is not nil, then we'll use this. And then you can simply call your class. Create a person, here without the new keyword, set a name, and then call the greetings method. Classes in Kotlin, it's the same keyword, class. Then we define a name, which is also an optional string. And here you can see that you don't have in Swift is the equals null. In Kotlin, every variable has to be set. Even if it's optional, you have to set it to null in this example. You could also set it to something, to a string. And then we have the greetings method. Here, a few things to notice. First, I don't set the string type, because the compiler is clever enough to see that greetings return the string. Then I also use the equal here. On the right-hand side, I have a really simple expression that's just a string, so I can just use equal to define my function. If I wanted to, I could use also the curly braces, like you would do in Swift. And here, a second thing to notice is the question mark colon. So as we did with name and stranger, here we don't use double question mark, but question mark and colon. We'll use it later. Again, you can create your person without the new keyword, set a name, and then call your greetings method. Initializers. So here we'll define a class, car. This car has wheels, which is an integer. And then you have to create an initializer with a string, a Swift class, because wheels is not optional, so you have to set it. And then you can create your car with wheels and use it. In Kotlin, it's a bit different. Here, we have what we call default constructor. So as you can see, it's not curly braces, but parentheses. So it has two functions. First, it defines the properties of the class. So here the class car has wheels, but it also creates a default constructor. If you wanted to add logic to your car, then you can add the curly braces. Again, you can use your car and check the wheels. Struts in Swift. Struts are nice. They are value types. If you adopt the equatable protocol, you can directly do a comparison of struts. It has a default description, so that's useful, for example, for debugging or other things. Here, we'll define the struct plane. This plane has wings. And as you know, or as you can see, you don't have to define the initializer for struct in Swift. You have to do it for classes, but for struct, the compiler knows how to create an initializer for you. Kotlin has data classes. So you use the data class keyword, and then like for regular classes, you create a default constructor with wings, and then you can create your plane. Data classes also have equality operator and toString and the same set of features like struts. Big difference. Struts in Swift are value types. So here we create a plane in plane 1. This plane has 2 wings. And then we copy plane 1 into plane 2. We change the number of wings of plane 2 to 4 wings. And then when we check the number of wings of plane 1, it's still 2. Because we did a deep copy of plane 1 into plane 2. So when we changed plane 2, plane 1 didn't change. That's different in Kotlin. If you do the same, then plane 1 we also have 4 wings. That's because in Kotlin it's a reference type and not value type. So when you come from Swift and do Kotlin work, be careful with that. Plane 1 and plane 2 have the same reference to only one instance. And usually when you use struct or data classes, you try to create immutable classes, so it should not be a problem. But as soon as you have mutability in your classes, then you have to be careful. Typecasting. So first, let's set the base classes for it. For the example, we have a protocol shape that has an area method. And then we define the struct circle that adopts this shape. This circle has a radius and then implements this area method. In Swift typecasting, so here we'll define a method called DisplayShape that takes a shape. And then we have this infamous if-let of Swift. If-let circle is of type, if shape is of type circle, then inside this block you can use circle.radius. Circle is circle. And then you can use your shape area. And then, as an example, create your circle and call your shape. Kotlin is a bit different. We have SmartCasting. So again, DisplayShape, which is a function that takes a shape. And here we have if shape is circle. So inside the block of the if, the compiler knows that shape is of type circle. So you don't have to redefine a circle constant. The compiler does SmartCasting, and so you can call shape.radius. The compiler knows that shape is of type circle. Then you can also call your area method and create your circle and call it. Guard in Swift. So again, let's define the play with shape method, and then we have this guard construct. So if shape is of type circle, set it to the circle constant, otherwise return. And then you know that circle is of type circle and you can use it. Kotlin doesn't have guard, but it has early return. So this line could be a bit hard to read when you come from Swift and you don't know that, but let's split it. So again, we see that we have question mark colon that we had earlier with name and stranger. So if shape is of type circle, then we assign it to the circle constant. Otherwise, we execute the right-hand side and we return. So that's how you could do early return in Kotlin without this guard keyword. And here, we have the circle, and we know it's of type circle. All right, time for the demo. So I will show you an iOS app, then an Android app. I already implemented the stuff around the example. So it will be a simple UI table view and then a recycler view on Android. I will not show this. I will not talk about this. What I want to show you here is the language. So you just have to know that there is some code that does the view stuff. We will just not see it. All right. I have a smaller screen than usual. Oops. All right, so I will just show you my simple to-do app that calls a backend, an API, and then shows a list, a table view of to-dos. As you can see, it can be a check mark or a cross, and then a title. So we'll go through the Swift code first and then convert it to Kotlin. So first things first, the to-do struct. The to-do is adopts Codable because we want to deserialize it from the API, JSON. It has an ID, a title, and completed to say if I did my to-do. Then we have an extension method on the to-do. It's just a summary method that returns a string. We first check if the to-do is completed, and if it is, then we return a check mark, otherwise a cross. And then we concatenate it into the emoji on the title, as we could see in the app. Then we have our API client. So first we'll define what the API client returns. So if you are using Swift 5, you should use the result type. But here, for the sake of this example, I will do it myself. So we define the result type of the API client. It can be either a success with a list of to-dos, or it could be a failure with an error. And that's what we'll return. Then we define our API client. We have a simple to-do method with a callback. This callback takes our API response and returns nothing. And then we have some iOS code. I use URL session for it. So I will simply create a data task for it and then implement my callback. So first we check if, let me increase this, okay. So first we check if we have an error. If we do, then we call our callback with a failure. Then we check if we have data. If we don't, we call the callback again with a failure. And finally, we use JSON decoder to decode our JSON, try to decode it, and if it succeeds, then finally I can call the callback with a success. And then we'll call our API client from our viewcontroller. So here I have my getToDos method that uses my API client, calls my to-do method, and then implements the callback. We get a result, which is this API response I showed earlier, and then we do pattern matching. So if result is of type failure, then we unwrap the error from the enum. Then here we just print it. And if result is of type success, then we again unwrap to-dos and then set it to our table view data source. All right, so now we can take our code and convert it. So what I will do here, I will simply copy it and paste it into Android Studio. So that's what I'll do. As you remember, we don't use struct, but data classes. So I do my data class. Kotlin doesn't have codable, like in Swift, but I will simply use serializable from Kotlin. And I will change from the curly braces to the parentheses to create a default constructor. As it's a function, I have to add commas. And finally, we use booleans and not bools in Kotlin. And that's it. We have our first Kotlin class. Let's create our extension. Again, copy-paste it. In Kotlin, it's a bit different to do extensions, so I will simply remove the extension part here. I change func to fun, and then here's how you do extensions. You just you use the class name first and then the method name. So here, todo.summary is an extension on todo. And for the return type, you change the arrow with a colon. We change let to val. And then in Kotlin, you don't have ternary operators. But that's fine, because everything is an expression. So I can simply use if. So if completed, check mark. Otherwise, cross. Sorry, else cross. And then that's how you do ternary operators in Kotlin. Then I change my string interpolation into string templates. And I have my extension on todo. Now we'll implement our API client. First, the response. So Kotlin doesn't have enums like Swift does, but it has something called sealed classes that does almost the same. Oops. So I'll create my sealed class API response. And what you have to do is you have to create subclasses for sealed classes. So I will just do my data class, success, that has to-dos, a list of to-dos, and that subclasses API response. And the failure class, the same. It has an error, which we'll use a string here and subclass the API response. And that's it. We have our API response in Kotlin. Let's do the to-dos method. I will first only take the method signature and copy it. And again, change stuff. So I remove the C, I keep the to-dos name, I keep the completion handler callback name, I remove escaping because that's not used in Kotlin, and then I almost keep the same signature. I have to remove void and use unit instead. And we have our function signature here. So in iOS, I used URL session, which is iOS and not Swift. So here I will use retrofit. So instead of copy pasting, I will just do it myself. Oops. So here I'll just call my retrofit service here. What I have to do is implement two methods. Oops, it doesn't want to import anymore. What happens? So I have to do the onFailure and onResponse method. So first, the simple one, onFailure. So I directly call my completion handler. I create an API response.failure data class. And we have our onFailure. And then I'll do the same for the success. I have to take the body from the response of retrofit. Oops. And then I call my completion handler with a success. And here it fails. Why does it fail? Android Studio tells me that body is an optional, whereas the success should not have an optional. Why? Is just because retrofit is not sure that it can give you always the correct type, so it returns an optional. The body method from retrofit returns an optional. So I will simply check if it's null. If it's null, then I call my completion handler with a failure. And then I return. And then magic happened here. We have our body, which is now with a green background, because the compiler knows that if the body is null, then you return. So after this line, the compiler knows that body is not null. So it does SmartCasting, and now you can use body as if it was not null. That's pretty nice in Kotlin. Last part for our conversion, the viewcontroller. So again, I will copy paste it and adapt. I have my load to-dos method that I will just implement. Oops. So I have my API client from we just defined. I have my to-dos method. I don't need weak self because we don't do that in Kotlin. I keep result, which is an API response. And then instead of in from Swift, I use an arrow. Then I'll do pattern matching. In Kotlin, you use when instead of switch. So when result is of type failure, then print, for example, result.error. And if result is of type success, then set my to-dos. And we have our pattern matching. Few things to notice. So in Swift, we had unwrapping, so you could directly use error. You cannot do that here. You cannot do failure with, for example, to-dos. But you can directly use error. As, again, we have SmartCasting, so we know that result is of type failure, so we can use error. And here, we know result is of type success, so we can use to-dos. And there we have it. We have our Android app. We converted using copy-pasting and adapting. And hopefully we'll see it. Yeah. So let's go back to the slides. Thank you. So in summary, we saw the basics of Kotlin. We saw variables, classes, typecasting, pattern matching. The code conversions was quite fast with all my copy-pasting. And we saw that Swift and Kotlin are fairly similar when you have the basics. And a lot of patterns from one language can be used with the other. If, for example, you read Swift by Sundell from John, or you just went to the talk from Soroush, most of it can be used in Kotlin as well. And that's pretty great. And I like that you can learn for both sides and apply to the other. And that was just a start. In Swift, you could use protocol-oriented programming. In Kotlin, you have coroutines, for example. And there's a lot of stuff to use and to learn and to share. So I think that if you are a Swift developer, you really should learn Kotlin, even if you don't use in production. And if you're a Kotlin developer and not a Swift developer, you could do the same. And I think that everyone can grow by learning the other language. Thank you.